Hey there folks, 2026 has been the year of agents. A lot of engineering teams around the world are trying to understand how they can reliably bring agents and multi-agent workflows into their ecosystem and make it work at a cost that makes sense for them. Along with introducing reliability and solving issues that come at a production level, right? Hopefully, at the end of this video, you will have a framework, a decision-making framework, where you understand, is an agentic workflow suitable for what you're looking at? How does it make sense from a cost perspective, latency perspective, and several other common decision points, as well as knowing the best practices on how this space has evolved, and therefore what part of the agentic ecosystem you should pick for building your specific use case, right? Now, to understand this, we have to move a couple of steps back, a few years back, so we understand how this whole space evolved. And in fact, it is beautiful, right? It's almost a natural extension of, for those who were in that space at that point in time, I think all of us were trying to do some of these things, and today now you have wonderful frameworks to make this happen, right? It's almost a natural extension in which the space has kind of evolved. Okay, so let's move 2 steps back and let's talk about LLMs, where all of it began. Now, when I say the word LLM, large language model, probably what comes to your mind, the first thing that comes to your mind, I'm guessing, is ChatGPT, right? ChatGPT, Gemini, and these sorts of your favorite AI model / tool of the day, right? What I'd like to outline here is ChatGPT and Gemini. These are actually complete products. It's not just the model, it's model plus engineering around it. Engineering is, you can call it a scaffolding, which is around that model to give it certain superior capabilities, right? So the model is at the heart of it, but there's additional engineering as well, right? Now, if you look at the second diagram here, you can see that we have the foundational model here, right? It's at the heart of it, but there's a lot of other engineering around it, okay? What I'd like to bring to your attention here is, without all this scaffolding, right, all this additional engineering around, a large language model is inherently stateless. So if you remove all of the surrounding stuff, right, around it, what you get is this diagram 1, which is on top here, which is input, LLM, output, right? What this means is, this language model, the output it produces is completely dependent on the input it sees. Whatever input it sees, it doesn't have any memory or any understanding of previous inputs that are there, or of any other foundational other intelligence apart from what it has been trained on, right? So this instance, whatever is your question, your comment, it will throw corresponding output with respect to just keeping that input in mind. That's it, right? This is why it is called as stateless, right? There's no sense of state. It doesn't have any foundational memory, right? No memory inside the language model is updated based on you sending a new input, right? But for it to become a chatbot, right? The chatbot is the application that ChatGPT is. For it to become that chatbot, we needed additional scaffolding. A natural scaffolding is memory, right? I need chat history, that specific conversation. Now, ChatGPT and all of these guys took it 2 steps further, where they said it's not only going to be this specific session memory, but we are going to remember preferences across multiple different conversations, right? Maybe you like a particular styling of answer, a kind of conversation style, or the model, if you in fact ask it stuff about you after you've had enough conversations, like even in an isolated new session, it's going to throw out some very interesting information about who you are, what you do, and etc., if you have had conversations around that before, right? So for a chatbot application, memory is very, very critical. So I have to remember the previous session history, right? And there are several other pieces of the scaffolding for it to become now an application. Important part, again, I'm re-emphasizing, what this means is large language models are stateless, okay? I have to now decide in this input, what are the additional pieces that should go, right? So if you just go 1 step back here, the user sends a specific message, right? You have typed out a message saying, can you teach me about agents, right? This message is not directly sent to the LLM. This message is part of the input. The input is composed with it will now say, okay, here is the user message plus here is this chat history, the session history, which was there earlier on, right? Now, in the context of this user query and this session history, if we have incomplete information, we will then have tools. So web search, for example, would be one of the tools it will have access to. So it will be able to open up a browser, search additional pieces of information, retrieve those pieces of information, right? If to answer the specific question, there is a bunch of documents that it can reference, it will go to those documents, figure out what are the relevant pieces from that, and get that as well into the input. So your input is composed to answer your question in the best possible way, and you provided all the information is required to answer that question. So in fact, you will be giving it, in this instance, if you're asking what are agents, right? So you'll be giving it the web search results, you'll be giving it additional documentation. If there's any other code execution related elements that need to be done, there'll be a sandboxed environment as a tool, etc., right? So additional data from different sources, external, internal sources, along with session history and etc., will all be part of you composing that input. And then the model will say, okay, you have now given me so much of information. This is the question I have to answer using all this information along with any foundational information that I was trained on. So I was trained on Reddit data, Twitter data, books, etc. So along with all the foundational information I was trained on and the specifics that you are now giving me, I will now produce an output, right? So to convert this whole ecosystem to something which has memory and make it very effective and efficient, a lot of this scaffolding is required. Right? And the specific aspect I'd like to first focus on is how this input is engineered, right? Because it is engineered. You are saying not all the memory. Maybe I have 25,000 messages before, right? Not all of that memory is very important. Only certain parts of memory is important to answer this question, right? So you're engineering what is being seen as the input. Now, this is also often called as context, right? It's the context. Context is nothing but what is the model seeing? Okay, it's your input plus a lot of this additional engineering pieces that it is increasingly seeing. Okay, so what I'm going to talk about right now is, I know the larger scale is for us to understand agents and multi-agent workflows, etc. But this is a very, very fundamental foundational aspect that needs to be looked at because context becomes a problem. Large contexts also become a problem, right? You might imagine right now that why don't I just stuff a lot of different data into this model and it can just throw out some answers, right? I'm getting ahead of myself. We will discuss this later. But context engineering, efficient context engineering is very, very important, right? So just going 2 steps back, right? This is engineering, right? I gave you a very quick teaser on the kind of engineering that happens on the context side. It's done at the product level. At a user level, way back when LLMs were first introduced, became really popular through ChatGPT, a lot of people started doing prompt engineering, which is the product guys, those on, say, OpenAI side, they do the engineering required around the product. But can I do something as a user myself to make my answers more effective for what I'm looking for? Right? It's possible that the model has been trained on a lot of books. You guys might have commonly heard this, right? These models have been trained on large repositories of books, Wikipedia data, a lot of internet data, Reddit, Twitter, etc. But if you're doing an auxiliary task, let's say in this instance, you're doing a task like sentiment analysis, where you're given a question saying, you're given a comment saying, very informative video. Is this sentence a positive or a negative sentiment? Now, a large language model has not been trained exactly on this task, right? It's a classification task where you're telling, this is a positive example, this is a positive comment, or this is a negative comment. The model has not been trained on this, right? So you say in certain instances, I will now give the model some assistance. I'll give it a few examples, and that's why it's called as few shot, because you're giving it a couple of examples. You're saying, this video was amazing. That's positive. That's a positive sentiment. What you're saying doesn't make an iota of sense. That's a negative example. And given these two examples, can you now tell me, very informative video, is it positive or negative? There's a question mark here, right? So this is called as few shot prompting because you now give a couple of examples. And there are several different kinds of prompting techniques, which at a user level allows us to give more relevant context to the model. Okay? This is part one of context engineering. How do I craft the input to an LLM? Okay, it became very, very popular a few years back. Today, as models are getting more and more powerful, some of these techniques, especially some of the basic techniques, might not be required, especially for the more common general purpose tasks. But if you're going in at a very domain specific layer, if you're looking at niche domains, or not even niche domains, if you're looking at really big popular domains, finance, law, etc., giving examples, because these models are not been exactly trained on that kind of data. They don't have that intelligence. If you ask it, can you tell me the difference between PAT and EBITDA? Maybe it has that information, maybe it doesn't have that information. Maybe Gemini has information, ChatGPT does not, right? Or OpenAI's basically models do not, right? So, I mean, that's not necessarily the case. I'm just giving you an example, right? So, when you're working on these niche domains, some of these prompting techniques still come in handy even till date. And they do give you a slightly better answer. It's like you saying, I'm giving you these additional pieces of context for you to answer this the way I want you to answer this. Right? Some people might not consider the second comment here as negative. It might just be criticism, right? It might just be critical. They might say it's neutral, right? But you are now telling it, I want you to look at it from a negative lens. Even this, your bar for what negative is a little bit higher or lower, I don't know, right? So prompting techniques, part one of context engineering, which is on the user side, right? Now, user side is one part. Now on the engineering aspect, on what is done within the product, and depending on what part of the, in your own agentic workflows, when you guys build this kind of stuff, you will have to do some context engineering as well. In fact, if you use a lot of these agentic coding tools, you will see that there is context engineering in there. Right, there are techniques for making your context more smaller, efficient, etc., etc. The stuff that's going on in the background. In fact, if you guys have in fact noticed, do take a look next time. Right. Nowadays, also there are agent SDKs which are becoming more popular. I think Anthropic has its own one out as well, where a lot of these this harness is in fact available for you already. Right, and I think there are some other libraries as well people are working on. But a lot of this harness that you're seeing around this context engineering bit is already available to you, right? But in case you are building it from scratch for whatever specific application that you are working on, you need to understand these different pieces. Okay, so coming to the engineering aspect, 4 large levers that you're looking at to manipulate the input and make this stateless engine into something which is stateful. Okay, memory, which is session, user, entity level. Retrieval, which is me looking at, maybe getting some curated data of existing documents that it doesn't have access to. Tools, which is giving it the ability of, specific functions and capabilities like a browser and things like that. MCP servers, again, another way to get data. Okay, we'll look at each of these in a little bit more detail. They all warrant their own longer sessions, but giving you an overview of what are the things that you have to build. Okay, so let's talk about the first two, which is memory and retrieval. So memory is probably the simplest because you have interacted, I think, with enough number of chatbots to understand that you need to have a session level memory, which is just history of that conversation, right? Pretty simple. User memory is across different conversations, are the specific preferences that the user has communicated to you. By you, I mean the product, right? ChatGPT in this instance, for example. Entity level memory, which is any specific aspects about you, for example, about people, projects that you're working on, stuff like that, right? So different kinds of memory has to be curated and stored. How this is done is a different conversation altogether. For now, you need to understand that effective context management, right? When you're managing your context, what the input is, what the model is seeing as input. This is very, very critical for not just simple large language systems, which are like a single workflow, but also multi-agent workflows, right? You understanding how do you compose this memory. Okay. The next aspect of this is, like I mentioned, there is a high possibility that there are very specific documents which are not part of the foundational memory of the model itself. So examples of this is, maybe at a company level, there are some company level documents. So the products that you're working on, the product documentation, etc., that the model obviously does not have access to. So if you give it any question about that, it will be an internal thing, right? So it will not have any idea about it. In those instances, that's where, there's a lot of conversation that's going on Reddit and so many other places where folks are asking, hey, are RAGs dead? Is it worth learning about RAGs in 2026 and 2027 as depending on when you end up viewing the video, right? RAGs will always be relevant. The reason for this is there will always be specific data that the model is not trained on, right? These models they're general purpose models. They might not be great on the specific domains and specific problems that you are working on, right? So giving access to that specific pieces of documentation, and now when a question, so what's the core idea behind the RAG, right? Retrieval augmented generation, right? So for me to answer a specific question, the question that's been asked is, can you tell me how does this feature, let's say for example, at 123 of AI, if you go to our website, you will find that the grind 75 ml, it's an interview preparation list. It's a really popular list that's there. So let's say you have a chatbot sitting on 123 of AI and you want to understand better about grind 75. If you just type on ChatGPT, for example, can you tell me about grind 75 ml, right? Probably it will not be able to tell you about it. Gemini might do something slightly better, right? For reasons I will explain. But rather than, none of them will probably be able to go into it in too much detail unless it's something super, super popular and it's actually been trained on it, or there is external access to that in some way, right? So this interview preparation list for machine learning, grind 75 ml, if I have all the questions, right, and I have similar such other pieces of information about 123 of AI. So the other grind list on LLMs, which is there in our platform, the other interview preparation, the machine learning design studio. So all of this documentation around our product, and I give that to the model. And basis this question, now the model will, not just the model, but essentially we have a little bit of engineering, there's a vector database in there, etc. We'll now be able to decide out of all of these pieces of documentation, which is the most relevant piece of documentation that I should retrieve so that I can answer this question the user has asked most efficiently. Okay, hope this makes sense. The idea here is the model does not have information to answer this question. So you are providing it information and there's a little bit of engineering to retrieve the most relevant piece of information to answer that question. Okay, you can go and read more about RAGs, but this is again a very important aspect of your context engineering, because this is additional information that will go into your context to answer it, right? If it's not in the context, it can never answer these kinds of questions. Moving on, so memory RAG, I think we spent enough time on this. We will now move to the other couple of things, which is tools and MCP servers, right? Now RAG to a large extent would focus on, say, maybe internal documents and things like that. But let's say you want to give general purpose access to external documents. Here are where tools come in. So tool is, you could, for example, tell the model that you have a particular function that can open up a web browser and search and say scrape the HTML and specific items in that web browser session, and therefore you are giving it now search capabilities. Right? It can go and access anything on the internet. This is a tool. It's a simple function, right? You have a lot of libraries nowadays that you can use to open up a browser, etc. You can function this as a tool and tell the model, you have to now decide when to use this tool, right? It's not, by you, I don't mean me as the engineer behind building the system, but I'm saying you as the model. The model has to now decide, when should I do RAG? When should I use this tool? And all of that basically means you're increasing the level of agency. How you're basically making the model more, or the system more autonomous. Okay, we'll come to that, right? But tools here are you saying, can I go and say, give it capabilities, specific capabilities, right? So searching the web is a very specific kind of capability. Giving it a sandboxed environment where it can write code and execute code. Very, very important. right? This was in fact one of the key pieces which made it almost makes it like a self-evolving system, right? It can write code on its own, execute code on its own, and retrieve results based on that. Right? It's very, very powerful. So the idea behind all of this is, again, this is all from a context engineering perspective where you're trying to construct the input, right? So hopefully all these different pieces that you might be seeing out in the world are connecting together, right? What's the purpose behind RAG? What's the purpose behind these tools, right? And the final piece, again, something very commonly thrown around is MCP servers. Again, when you want to give the model access to external data, several providers would create MCP servers, and that way your model can directly communicate and retrieve whatever information it wants from those MCP servers. Okay, so it gives you access to, again, external data, external documentation, etc., right? And additional tools which are part of that ecosystem as well, right? What's the purpose of all of this? The purpose of all of this, the North Star is that LLMs are stateless, and you are trying to say, what all do I have to put into that input so that this model can most efficiently, and so efficiency can be a function of how correct is the answer going to be, how fast is the answer going to be, how much in depth is the answer going to be, right? You can have different levers to how you want to evaluate the quality of answer, basis which you will now engineer and give it all of these capabilities. So you will tell it, I'm going to give you memory. You will have capability to access different documents through a RAG based mechanism. I'll give you tools, right? I'll give you access to certain specific MCP servers so that now you can retrieve any other piece of information that you need in the most, say, easy, natural format, right? So a lot of you might be thinking that, hey, searching the web versus MCP server, right? Searching the web also, you can retrieve some of these, like let's say you're looking for some API documentation I want to integrate with Stripe, right? I can just go and search on the web on the documentation. But the specialty behind these MCP servers is that they make it standardized, right? It's almost like a standardized operating system to communicate between multiple ecosystems. And because of standardization, the accuracy goes up. But if you look at it from a web server point of view, web fetch point of view, the web fetch would actually be, every provider would have a different documentation, right? Stripe would have one documentation for integration, PayPal would have a different documentation, because the way English is written is different. Correct? And the way you order the sections, it has to do a little bit more of additional work, and whether that's been updated, etc., there could be things that are not compatible. But when you look at an MCP server, they make it a bit more standardized. And again, you can independently go and explore this, just like RAGs. You can independently go and explore MCP servers and tools and etc. But the North Star is this. This is how you are engineering your context in the most efficient manner. Okay, I think I spent enough time on this for you to hopefully understand the different parts of this ecosystem. Okay. Now, I've now given you a lot of different parts of this ecosystem that you can dump things into your input with, right? I can dump things using my web fetch, using my retrieve documents, using RAG, using the external documentation that I got through my MCP server, etc., right? You can dump a lot of things into the input, and then you leave it up to the model now to answer. Is it as simple as that? That's the question. Right? Is it as simple as that? So for those of you who obviously, who have been working with these large language models, or have seen how the costing of these large language models are done, it is done based on input and output tokens. You have a specific costing for input tokens and a specific costing for output tokens. So they are charging you, all these providers are charging you based on how many tokens are going on your input and how many tokens are on your output side. So if you stuff a lot of things and you err on the side of putting extra information in, if you're like, say, I'm a little bit unsure if this is going to be sufficient for the model to answer, so let it also pick from this source and that source and this and that and everything, and let's dump all of it, and the model will figure it out. It's awesome, it's big, it's got a big brain, so it'll figure it out. But the reality is, when you're building a system, you are not just looking at it from the level of how accurate it is. Accuracy we will talk about. There are problems that also come on an accuracy standpoint when you stuff your input this way, right? When your context window, right? So I hope now these terms you guys that you have heard of elsewhere are all connecting together. So when you're doing context engineering, it's now context window is basically what the model is seeing exactly, right? I mean, these are very fancy terms that people have given. It's largely what is the input the model is seeing at this instance in time. Okay, your context window would, if it consists a lot of tokens, your cost should be very high, right? Very high cost, because you're being charged on a per input basis, and perhaps if you look at it from an efficiency perspective, the model doesn't need all of that information to answer that specific question, right? High cost. Next bit is, if it's processing more, there can be more latency as well, right? Cost and latency, always there is a relationship between them. The third part is on the accuracy bit. Models have something which is called as a needle in a haystack problem. There's, again, if you search for needle in a haystack LLMs, you'll get a bunch of research papers that talk about this. So needle in a haystack is all about, if you give the model a lot of information, a lot of items in the context, it has to answer basis that context. Sometimes it's not as efficient in picking out just the relevant piece for it to answer. So this is the needle in the haystack. So what is needle in the haystack? It's a really small piece it has to pick up from a large haystack, and it finds it difficult to pick that piece up, right? So even if the relevant piece of information is present, it might not be able to do the job very well if your context is not efficient. Okay, so you're actually you're engineering this ecosystem based on the problem that you're seeing. So the problem that you first saw was LLMs are stateless. Basis that, you said, okay, let me add state with all of these items. Now when you add state with all these items, the new problem is now coming out saying that I have to now make the context window efficient also, because I am having high cost, increased latency, needle in a haystack and all of that. So I can't just randomly add things. I now have to specifically look at how do I make this context window efficient, right? So every engineering kind of design choice leads to more engineering problems, and I'm hoping that more engineers and folks in the AI/ML space will continue to have their jobs as long as these problems stay. So needle in the haystack problem, right? And there's also something called a recency decay, which is that if you're giving it a very large context, sometimes it might forget about certain kinds of information, right? So if it's processing, let's say, if it's processing in a top-down manner, maybe if the most recent piece of information are within the within the chat history, in the most recent chat history, that can kind of be like buried or overlooked. Okay, so these are problems with the context window. So you figured out that I have to now engineer the input, but now I have to also engineer the input efficiently so that all of these problems are solved. Okay, now when you look at these agentic systems, right, and I want to put this into what this means. I want to put the context window management into context for you. Okay, give you a little bit of background. People would like put, say, 100,000 tokens into, or 200,000 tokens. You sometimes look at these models and they do come out with a specification on what is the context window. So you look at some of the latest Gemini models and the Anthropic models and so on. They'll tell you we have a context window of 1 million tokens. Give us 1 million tokens. We'll be able to process that input. But the reality is, with these models, out of the 1 million tokens, you do have these problems like needle in the haystack, recency decay. All of this kind of comes in, because of which, empirically, through experimentation, there is a generic word amongst practitioners that anything above a 200,000, 300,000 sort of context window, 300,000 tokens context window. The 300,000 is very large, 200,000 is very large. Okay, context window, it is inefficient above that. Okay, we do a reasonably good job within a 200,000 context window, even if the model's capacity is I can process 1 million tokens at a time. Okay, so these are some practical, lot of, if you get deep into it, you will understand there are a lot of issues. We have come a long way, but there's a lot to kind of, there's a lot to solve for still, right? What else? I think there's one more important point that I wanted to outline about the token size, right? So 100,000 tokens, 200,000 tokens, 200,000 is what I largely gave as a very empirical bar. How large is 200,000? I think you should be able to imagine this, right? 100,000 tokens. Now, if I were to do like a back of the hand calculation, 100,000 tokens, if I were to assume for simplicity of calculation, one token is one word, simplicity of calculation, right? So 100,000 tokens and let's say your a book is a good, I think all of us understand books reasonably well. So I think on a single page of a book, I'm guessing maybe 300 words could be there, right? Or if I were to write a page in a Word document, I think 300 words might probably be there. So when you say 100,000 tokens, largely what I'm looking at is 300 pages, right? 300 pages, if I'm not mistaken. Yeah, so obviously I'm making an assumption here, one token is equal to one word. So you're stuffing that kind of data and you're giving it that much amount of data in just 100,000 tokens. Correct me if my math is wrong, but it is a very, very large scale, right? So hopefully you can envision that and see that when I'm saying 200,000 tokens, you're saying, I'm going to give you 500, 600 pages of data and use 500, you as a human, if you have to process 500, 600 pages and synthesize the most important parts to answer one specific question, imagine how tough that is, right? Obviously, you have the privilege of compute power as a AI model, and therefore your capabilities on this should be superior, no doubt. But I just want you to appreciate the challenge that is there in the problem. Okay. So context window management, right? By the way, hopefully you guys are making notes on each of these parts. Not everything is necessarily, we'll link the slides in the description, but all the same, you can sort of make your relevant notes, take your screenshots, do whatever is relevant. You know, in conversation, there might be a few things that that I might have mentioned. So if you find that valuable, do make sure to take some notes. Yeah, one thing that we really focus on is that we don't want any of our sessions to be passive. They have to be active. Now, if we were on a actual call and we were discussing all of this, it would be a much more interactive discussion. There'd be a lot of instances where there'd be back and forth, but unfortunately we are in a video format here. You guys are probably listening to me. So I think the way you can make this active is by taking notes, asking any questions that you have in the comments, and we'll try to get back to you. Passively, parallelly opening up, your favorite AI tool and asking questions about certain things that are not unclear, etc., etc. Okay. Now, coming back to context window management, right? So we said we have to now efficiently engineer the context, right? So there are certain tricks that are done, and for those of you, for example, use some of these coding tools, you might have noticed there's a compact that's there in your Claude, for example. I think OpenAI also has something pretty similar on Codex, right? So this kind of does like a summarization of the context, for example. There's also a sliding window based mechanism where it stores, like for say solving the recent CDK issue, the most recent conversation is what it maintains, rather than giving it really, really old conversation. So things like that. So there are a lot of engineering solutions that have now come into being, which are again, all of this has to be tuned, right? Because you need to know when you summarize, you don't remove, if you're using a model again to summarize, it's a chicken and egg problem, right? A model is unable to understand what's going on. You're using again another model or another instance of the same model for you to summarize that piece of information, which means you need to be very specific on what the task you're doing for. You should ensure that that relevant piece of information should be there. So if you're building a coding agent, in your summarization, you should ensure that specific aspects of the code that have been pointed out, you have to create metadata and structure data in ways which is very, very important to ensure that the summarization is effective. Okay. So all of these are engineering challenges. If you're building your own agentic system, and we will come to agency as such, I've not really talked about the aspect of it being autonomous, right? But we'll come to that. But this is all very, very critical part of it, because all that we're talking about in isolation here multiplies when you are having like a agentic system with, say, even multiple agents and stuff like that. Okay. So context window management, efficiency required. Some tricks and tips around that are present in the ecosystem on how to do that, right? Now, we have talked about an ecosystem. Now, if I were to very broadly abstract it, I would call ChatGPT as a great summarizer, right? And what's kind of going in, if you look at the harness, you would have also heard this other word. So there's context engineering, context window management, right? And all the scaffolding that you saw, right? Context engineering is about what I effectively get into my input. Harness is not just on the input side, but if you look at the diagram we first had, there would be safety and guardrails, right? There would be how orchestration would take place, a lot of other aspects around how this system is would effectively produce an answer, and that's called as harness. So we'll talk about harness engineering also, but I'm going to talk about it in the context of, there's a lot of use of the word context, but in the context of coding agents, because I think these are the two very big success stories that we have seen at a public, at a huge scale, right? You have a product like ChatGPT and Gemini, which does great on Q&A. So on Q&A, what is the kind of stuff that is done? So there's a user prompt where the user asks, can you tell me more about regularization? Then let's say, because we're talking about AI, I have to ask an AI question. What is exactly is regularization? Then there's memory that's added to that. So A plus B, plus there's, say, tools, for example, some fetch of some 10 articles on regularization, and all of this is given as an input to the large language model to produce an output. So if I were to abstract out and at a sort of 10,000 feet level, I would largely call ChatGPT a great summarizer, right? I mean, there are other capabilities also. You can do classification, you can do a lot of things here, problems using something as general purpose as this, but I'd put it on the category for the sake of simplicity as a great summarizer. Okay, let's now look at another system, which is a agentic coding system, something like, say, Claude Code, right? And understand how does Claude Code work, right? And study of these agentic systems. I've still not defined what is an agentic system, right? But study of these kinds of agentic systems will give you insight into how you should design your own workflow. So if I have to build a coding agent, how is that different from a Q&A agent, something that does question and answers, right? So there are several things that you have to change. You have to change the harness, right? Harness is all the surrounding engineering around how exactly the answer is produced. So the harness would also include the context window management aspect of it, right? That would also change. Okay. In addition to that, all the additional tools it's given access to, what kind of guardrails are set, etc., right? So all of that. Interestingly, so change the harness, change the context. Interestingly, you will also have to change the model. Okay, and this is very, very interesting. So if you use the same model, ChatGPT, that's been trained on, say, Reddit and all of this kind of data, and ask it to do coding, write code, it's not going to do an amazing job. Okay, we will discuss in more detail about this, but whenever you're looking at, say, designing your own system, you need to understand that you have to decide how exactly is your harness going to look like, what is the addition, essentially the scaffolding around that is required around your model, how is your context window management going to look like, and what kind of a model are you going to use for your use case. Okay, these are three large questions that you have to answer in addition to several others, but this is a very important starting point. So let's look at this coding agents, right? Okay, so I think this now comes to a good point where we define what an agent is, right? Now, we talked about several of these different aspects, right? Which is, we talked about LLM, which is the foundational model itself. We talked about access to tools, access to memory, right? And access to harness, which is the additional engineering scaffolding around it. Okay. So when you have a combination of all of these things, you move towards, from just simple question answering, okay, to some system which is a bit more autonomous, that can now not just summarize, but do specific goal-oriented tasks. If you think of a coding agent, in reality, and something which, if you look at Anthropic's own lectures, they give a lot of the KT sessions and public sessions in their own YouTube channel. In fact, great recommendation on how they, when they kind of built out the whole fun fact, right? Claude Code was built with the aim of just being a coding agent, but they realized that it is a general purpose tool because it can write code on its own, and that kind of ability gives you to do anything, right? When you can write code on your own, in a sandboxed environment, that means you can do like SEO work, you can do development, like say front-end development work, you can do anything, right? So it's actually a very, very general purpose tool, right? Now, what is so special is that from just simple question answering, so ChatGPT itself, it also has agentic capabilities, right? Now, we would call it an agent specifically when the sequence of steps it has to do to achieve your goal, that is completely decided by the model, right? The model will decide, this LLM model, right? It has capabilities to then decide which tool should I use, what kind of memory should I use, and how I should break down this question that the user has asked to produce the answer that I'm looking for. Okay, so this is largely what I would say is an agent. It has capabilities to achieve goal-oriented tasks, but specifically it has autonomy in deciding how it is going to go about it. Okay, right. Now, agents specifically have something called as an agent loop. So inside this harness, now the additional scaffolding or harness that you saw for ChatGPT, that is slightly different. Now for coding agent, there's a specific loop in there, and this is where agentic patterns come in. Now, obviously, yes, agents would decide how exactly they have to achieve the end goal, but this could be a very open-ended problem, right? You just give and the thing is, several times, I'm kind of digressing here in a longer conversation, right? But it's very important for you to understand that many systems, you want repeatability and reliability, which means that if I give a particular question, I want the same answer several times, right? Or I want the same sequence of steps to be executed several times, right? Or a general ordering of how I should go about it. Okay. If you want to introduce all of, so you're saying that the model has autonomy, but you want to introduce determinism, right? Which means that you are trying to add some artificial structure to it, and those are where agentic patterns come in. Okay, we'll discuss all about this in just a bit, but hopefully the core idea of what an agent is would make sense, right? An agent consists of a foundational model with all of this additional scaffolding around tools and memory, and what makes it really powerful is this harness, using which it can then decide how am I going to achieve this task with all this additional scaffolding. Okay, I hope that's clear. So you're moving away from a single language model to now a harness which can now achieve specific goals, right? It's not just a summarizer now. You are now looking at something beyond a summarizer that can now execute things because you have given it a coding sandbox. You have given it specific tools which give it really a tremendous amount of power. Okay. So let us look at this harness, right? So I'm talking about this specifically from some of the information that I could understand about how Claude Code is built. Right, and if you there's a lot of work in early days where there's something called as Ralph loops, okay, and Claude and Anthropic's own team themselves say that they're taking a lot of inspiration from that to build their own version of the Ralph loop. And what this loop largely is very simplistic. Okay, it's very simple. There's nothing too complicated about it. I know the discussion has gone from understanding what goes into your input, which is the context window, context engineering, to now you're looking at this additional scaffolding and harness engineering and agentic patterns. A lot of terms being thrown around. So please make sure to create your own sort of mind map on this entire space. But hopefully I've taken you through a natural way of going about it. Right, about how the space has actually evolved, because every natural question results in the new engineering challenge and therefore a solution to that. Right. So how does Claude Code work? It has a specific agent pattern in it, where any task that is given to Claude Code or any of these codecs, any of these tools, they have a specific agentic pattern. That agentic pattern says, I will have a planner which will now say, given this specific task, can I break it down into a task list? right? That I have to do A, I have to do B, I have to do C, etc. Right? So you'll get a task list like this, what you see at the bottom that says, I'm going to look at this doc, look at this architecture MD, I'm going to look at all of this code, etc., etc. And all of these are required important steps for me to understand how I'm going to execute this task, right? So there's a planner. That planner throws out a task list of things that should be executed, right? Then what happens is that you have a generator. Okay, so planner to generator. The generator then says, I'm going to take this task number 1, I'm going to work through task number 1, right? Once I've worked through task number 1, this will be like a separate fresh context, a fresh context window, right? And it's going to work through task number 1 and throw out outputs of its understanding of task number 1. So planner, generator, and then you have an evaluator or a verifier, right? So the verifier, what it does is it will then say, have you actually correctly executed this specific task, right? So evaluator might then say, okay, there are certain things based on, I think, multiple aspects here, right? The evaluator might say that based on your learnings from this task, I have to update the task list, for example, right? Or I want certain modifications to this task to be done a slightly different way, right? Or I would say that, okay, I'm happy with what you have done, mark this as completed, right? So this is a specific agentic pattern that was implemented that says I'm going to have a planner that throws out a list of tasks. I'm going to have a generator that solves one task at a time. And then I'm going to have a verifier that says, okay, is this task done or not? And verifier/updater, right? Which then goes and looks at the task list and says, can I mark this as completed? Should I add anything additional to this? Etc. etc. Right? And the loop that is often commonly talked about, right? This loop is nothing but if all of the tasks are completed, essentially it tries to complete all the tasks, right? It says, okay, if task 1 is now completed, can I now loop back and say, can I now do task 2, right? Or what do I additionally need? And you keep continuing to do this process until all tasks are done. So if the task is not completed, it will go back. It'll try to say, okay, now given this new piece of information, what do I additionally need? And go through this entire process of generation, etc., etc. Right? And if all the tasks are done, it will just mark it as done. Right? We are now executed what the user has asked us for. Okay. This specific diagram here, the way I see it is the loop goes back to the planner, but at least from the way Claude and the way Anthropic had explained it, the loop goes back to the task list rather than the planner, right? But I have seen certain setups and certain kinds of models and designs where, you know, the verifier only gives inputs to the verifier itself, doesn't have the fundamental capability to add new tasks. The verifier gives that input back to the planner, which can then plan and add more tasks, right? So it depends on how you are kind of delegating the entire process, but I hope you get the idea on, you're given a very open-ended problem, right? So you need to give the entire foundational intelligence structure on how you can implement this. So you will tell it, first plan, give me a list of tasks, knock one task out at a time. For every task, have a verifier, and a verifier has a separate context. The generator has a separate context. The planner has a separate context, right? And you can loop through the generator and verifier until every single task is completed, and you know, go back to the planner, or you decide when you want to go back to the planner, essentially. Right? So this is an agentic pattern or a harness pattern, and this is part of the engineering. You deciding this harness and the scaffolding which is there is part of the engineering on you deciding how is it that this model or this ecosystem is going to write code in this instance, right? What's next? Context management at scale, right? So when I talked about this, obviously there are things that we have already talked about on why that context window is sacred. It's very important for us to manage that context window, and in an isolated fashion, what are certain things that we can do to manage that context window, right? We've had a very brief conversation on that. Now, when you come to coding agents, your code bases can be all the way from 1,000, 10,000 lines to millions of lines of code, right? So your context window filling up might happen really fast, Okay, so which is where protecting your context window and it is sacred, right? Like I mentioned, there are problems if a context window becomes very large, which is where there are certain specific interventions, and this is again going off of how Anthropic has designed, and of course now from them a lot of the world is adopting many of these best practices. They introduce sub-agents and skills. Okay, now as your say list of tasks grow, right? Imagine this, right? As your lists of tasks grow, for every task that is executed, you get a particular output on what all has happened, right? And that is additionally fed into the context. So your context starts bloating a lot, right? Which means it becomes inefficient. Now, if the planner has to relook at that to understand if everything is done and if it requires to add any new tasks, etc., it can become very inefficient, right? Instead, they devise something called as sub-agents. So sub-agents are, it's again just the model with all the scaffolding, everything, but a separate instance of that with a fresh context window, and that will execute only and only task 1 and give output of just task 1. So you're not doing everything in the same context, right? In your primary agent view, its own window, it will not be crowded. It will have only the final summaries, so to speak, right? It will not have every execution line. Okay, I went to this documentation, did this, did that, figured out this piece here, this is not relevant, that is relevant, etc. It will not have all that. It will have the final critical summary that it needs. The primary agent would have just that. The sub agent would have given that back as an input to the primary agent, which can then decide how do I take this further. Sub agents, very important. So this is where you're getting into a multi-agent system, because now you're having handoff taking place between agents. You have a primary agent, you have sub agents, right? And the primary agent is trying to maintain this longer context where it's saying I'm planning at a global scale and I want, some small sub agents to go and execute specific aspects. And it's also, when you look at these multi-agent systems, you have to be also very, very careful on if you are building something of your own for whatever your use case is, right? If you're having multiple sub agents executing in parallel, you have to make sure that their parallel execution, if it's hitting the same set of files, there could be things which are getting overwritten, right? There could be race conditions coming in. So you have to be very careful on ensuring that you distribute the work such that it is independent and doesn't necessarily overlap, right? Or there is an ordering to that, or there's locking mechanism, right? So things that are coming from the world of operating systems, the way different threads kind of work, right? So the design can get very complex. So if you now sort of zoom out and see how something like a ChatGPT or a Claude code is built, they consist of all of this kind of scaffolding, the harness engineering, context management, all of this into that, right? Very interesting. Now, when you're talking about context window from the coding agent's point of view, there is also something very interesting that they introduced, which is called as skills, right? Now, again, these all came as natural extensions, because as they used the product, they figured out that they already knew context window was a problem. So, okay, what if I have a sub agent as a separate spin-off with its own individual window? Is that going to affect anything else? No. Great. How do I handle parallelism, etc., right? Now, what are skills? Skills are, if you, let's say, are building an application for a specific use case in a specific domain, there will always exist certain things which are repeated, right? When you're talking to a model, you're talking through prompts. So there could be repeated prompts, and several times you might want to make this prompt really efficient, right? So maybe you do a few shot, chain of thought, whatever it is, really efficient prompt with all the surrounding information that is there, and some specific other functions associated to that to execute certain things. So all of this could be a single skill. So I'll give you an example. So let us say you want to build a SEO, AEO, GEO agent, and using my domain knowledge. So at 123 FAI, we write a lot of articles. So we want our articles to rank well because we put in a lot of effort into that. And today, nobody does it without SEO, AEO, GEO optimization, right? So obviously, being in the domain, I have some information on how this works, right? So let's say for GEO, AEO, what we have understood is it's very important. Now, GEO, AEO is if a question is asked about, let's say, how do you crack a machine learning interview at a senior level? How do you remain relevant in this space? Specific kinds of questions. We would want things that add 1 to 3 of AI that we are working on to rank well, right? And not just rank well in this specific case, ChatGPT give an answer that is from our using us as a source, right? So what we have understood is adding a FAQ section to articles, adding a TLDR to articles. All of this is very, very useful in ranking well. Okay, so this kind of information I will add it into my prompt and I'll build functions so that measurement can be done is to check if FAQs are there, and what is the density of these FAQs, etc. So let's look at from an SEO perspective. I think here that will probably be a good example. We would want to rank on specific keywords in case something is searched on Google, right? In this instance, we will say that, okay, I want to have my titles optimized, my titles and subtitles, H1, H2 tags all optimized, my meta descriptions optimized, right? There's a JSON LD schema, all of that to be optimized, right? And I should have specific number of images and a specific keyword density for the keywords I want to rank for, etc., etc., right? So you could have functions written to calculate the keyword density. And this would be part of that same skill on, let's say, maybe SEO optimization. So I have a skill that says I want to optimize an article for SEO. So that will use functions, which are essentially, you can think of them as pre-written tools, right? It will use those functions to then say, okay, now I will calculate the keyword density. Is there keyword stuffing? Right, too much of that keyword is used at a particular level, etc., etc. It will give a particular report, and then I'll then have another agent that works on that report to optimize each of those aspects, because now I have measurable items that I can optimize for, right? So that way we will have skills, which is a combination of prompts plus, say, other functions and tools for a specific use case, right? And SEO might be one, and why would I call it a skill, right? SEO might be one of the skills. Let's say you're building a larger marketing suite. If you're building a marketing suite, then SEO might be one of the skills. The other skills could be maybe writing LinkedIn posts, right? Or any of our organic social media marketing, right? Or creating, say, ad copies for ads, Jaran, etc., etc. Right? So you could have separate skills for all of them. Now, when you come to the context window management, this makes it efficient because you are no longer rediscovering and rewriting any of these things. The most efficient versions of these are already pre-written and pre-optimized. Okay, these could be optimized from your own personal workflows that you have realized that it's a natural extension. This should always be a skill. Or nowadays you can also have models write its own skills. Right, all of that is also coming into it, because it will then it has intelligence, right, to discover that for this task what's all required. Again, it itself will break it down into, if I want to write skills for myself, I would break it down into a planner that then can do research on SEO, right? The plan would consist of research on SEO and this and that and so on. It will obviously consist of all of that, but obviously if you have domain expertise, you would want to inject that domain expertise. So some of the skills that you would build might be very specific. Okay, so these are some ways in which context management at scale happens, and coding agents, specifically from the perspective of, let's say, coding agents, right? Okay, so we talked about harness engineering for coding agents, and we said let's change the harness, and the specific change in the harness that you saw was that now we have an agentic loop that is working in the pattern of a planner, generator, verifier, right? So this was the kind of harness change versus a summarization or a Q&A bot that we talked about in the first half, right? So that's the difference in harness that was there, because now the task is we want something which is goal oriented that can execute tasks, okay? But the question is the harness the only difference, right? And the answer, because I asked you guys to think about this earlier, right? The answer is that no, we have to change the models also, right? The general purpose models are not optimized for these sorts of tasks, for coding tasks, right? So it's important to train your models in the context of that specific harness, if that makes sense, right? So which means the harness in this instance would consist of, let's say, code summaries and the way code is written and all of that. Right? So that way, when you train it in that context, you will see that the tool selection will be far more superior. So if you look at a coding agent, what are some kind of tools it might have, right? So it might have exploration of the exploration of the repository. So it will have some read functions and so on, how it reads those readmes, how it organizes all of that, right? Etc. etc. So you'll have better tool selection on when what should be done. In the planning steps, you will have reduced hallucination, right? Your evaluations will be faster, more specific, because it is now continuously seeing more and more such loops. So every time a new version of Claude comes out, right? A new Claude Anthropic model comes out, what do you think is different, right? Are they training just on more coding data so more code, better code can be generated? In fact, if you train on a lot of GitHub data, a lot of public repositories of code, and I'm sure they've used a lot of that, right? Code quality is a big question mark. A lot of old handwritten code, it's not necessary it's of higher quality. Newer AI generated code is adding more and more to AI slop, which is making it even worse. It's like it's just making it even worse, because now your code quality is getting even worse. It's writing if if I ask Claude or any of these coding agents, Claude Code, Codex, to write a specific piece of code for a specific function, it will write the same thing in 5 different ways. There is no consistency to it, and 3 of those 5 ways will be unreadable, right? So that's a bit of a digression, right? I'm sure all of you guys would have also experienced similar things, right? Our skill set at reviewing code is getting better and better rather than writing code, because we're doing lesser on writing code and more on reviewing code, right? But anyways, coming back to the point is that these coding models, when they're kind of getting better, what is the fundamental change? The fundamental change is of 2 parts. One is obviously, yes, they are using more GitHub repositories, more code data. They're signing up contracts with several companies which are open to giving access to their code base, so training can be done on their code base, so better quality code generation can happen. So that is happening on one side for sure, yes. The second bit is that the code that you are writing, right, there is a clause that all of you can see in any of your agentic. So we use a bit more of Claude Code. We're using Cursor way back, but we found Claude Code to be more efficient from a cost and accuracy perspective. So there is a clause which is there, which if you go to the settings, you'll look at it, whether your code can be used for training purposes. So all the code that you generate will also be used back as training data for them. So these are reasons why it's continuously getting better. Whatever you write, it's also using that as input, because you have gone through iterations, figured out what's correct, what's incorrect, what do you like, what you don't like, etc. etc. So all those pieces of input, it will use it further back, and in the context of that harness. So what is the kind of trace that will be available? When you ask Claude Code to execute something, Codex to execute something, right? It will say, I have chosen tool 1, I've done this, I've done that, I've written this function, etc. etc. All that information is going back to Anthropic, right? And they are having access to, of course, you can turn that off, that I don't want my data to be, for you to train on my data and stuff like that, which at a business level, obviously you will want to do, right? For those of you who are hobbyists, right, or who have not explored or seen that option, your code is being used, right? So they are training their model in the exact harness. So they have said, I'm going to have these tools, I'm going to have this, etc., etc. And the user has chosen this way to go about it and all of that. So they'll have information to that. So in the context of that harness, it will now, the model will be trained. So that's why at every iteration, the model is getting better and better, right? And there are some other problems also in this ecosystem. So the 2 ways I talked about is one, them basically using your code and them using all this public repository and business tie-ups and all of that kind of code. And there's also other long-range problems which are there with coding agents in general that they continuously try to solve, basis which now they say, I have now a new version that comes out, right? But it is important for you to have a model specific to your task. Okay. In this case, for a coding agent, there is high value to train it in the context of that harness, right? What are the tool choices? What kind of code is written? What order? What is the plan that is generated, etc., etc. With every iteration, it gets better and better in terms of less hallucinations, lesser cost, right, etc., etc. Okay. Now, we talked about So multi-agent systems, right? So we talked about a kind of multi-agent systems. One kind, which is that, let's say you have sub-agents and, task is delegated to the sub-agents and so on. But there could be other and more complex. So in this case, if you still were to imagine it, it's like a tree structure where you have a parent agent and you have some child agents which are executing things and they're getting things back to the parent agent. So there's still a centralized control, right? There could be other more complex workflows where there's not a centralized control as well, right? Now in each of these cases, you need to understand a lot of nuances, right? So when you're looking at multi-agent systems, they do unlock new levels of capability, no doubt, right? But you need to solve for enhanced context management, how parallelization of tasks take place, how distributed development takes place, right? And how all of this synthesizes together to give you the final answer, right? So multi-agent systems can get even more complicated. If you don't have a single agent system cracked, you have to think, should you go to multiple agents at all, right? Now, one of the things that I hinted to when I talked about what happens when a new model of Anthropic comes out, right? How is the coding model getting better? So we talked about two ways in which they were improving. Third way was some of the core problems that exist in these coding ecosystems, and in general we can extend it to a lot of agentic systems, right? If you think about it, each of them are very specific engineering challenges, right? Planning. How do you actually size and decompose work before execution? It's very important. How do you decide these are the exact correct steps? Because sometimes there is multiple ways to do a particular item, right? I'm sure when you guys yourself execute things on your own, you and your friend might do the same task in a different way, right? So how you plan for it could be very different, right? Context is another problem. We have talked, I would say, pretty extensively about context and context window management in the last hour or so, right? But that is an important problem which is being worked on, and a lot of work is still ongoing in this world of context, right? Verification. Now again, you have to now evaluate whether the work is complete and correct, right? With respect to what was asked. So that's the third problem. Next comes execution, right? Now, how do you handle, what is the ordering of calling of things? How do you handle collaboration? When should you delegate? When should you not delegate? If you in fact look at if any of you guys have used these coding agents, right? And we extensively use it here for our work. And I think most teams around the world do use it. If you're in any kind of development space, you will sometimes notice that there is no, it's not great in necessarily delegating or moving to sub-agents and things like that. Sometimes you have to forcefully tell it, please use sub-agents. And in fact, the most recent release that Claude Code had, they had in fact put out saying that unless explicitly mentioned, correct me if I'm wrong, I think I read this somewhere, and without verifying, I'm using it as a part of my workflow now, which is you have to specify specifically saying, please use multiple parallel subagents, use 5A subagents, 6A subagents, things like that, right? My default is usually use as many parallel subagents. Please don't hang my system, right? So yeah, but which means that these are unsolved problems, right? And these are engineering problems which are still being looked at. And final part comes on observability, right? And on observability, I think one of the key things, a lot of work that Anthropic has done is on long running sessions. If you want to keep a window running for 24 hours and it doesn't lose its context, right, and still continues to efficiently work, right? And you don't want things like this. Genuine large problems that exist in this space, and you guys should read about it if you want to really understand the nuances in agentic systems. And I hope the last hour has given you that nuance, as you have understood that agentic systems are not as simple, right? There's something called as agentic drift, which is that plan versus execution can be different, right? If you think about it, all these issues are from the world of the way you have looked at the system, right? We talked about planning, execution, verification, etc. Any kind of project, a project management perspective, all of these aspects come in, right? So if you, let's say, want to build a building, you would plan how exactly you want to lay the foundation, what's the floor plan going to look like, what kind of materials you need, etc., etc. So you come up with a wonderful plan. Let's say your plan is amazing and you've broken it down the best way possible. But when you're executing, you might find that, okay, I don't find the right cement that I'm looking for, so I will compromise on the cement, right? Or maybe our pace of execution that we were expecting is not at the same pace, so I'll have to hire more workers, right? So a lot of things happen. So I'm just talking about standard construction process, right? Or there could be other external factors that come and intervene. So maybe rains start whenever you're building something and you're not able to put cement because of that. Cement has to dry or whatever, right? So there could be other issues that come in, right? And this is just one example. So any kind of large project, you have these project management challenges that come in, and all those challenges also find its way into these agentic systems, right? Agentic drift is a real problem. Plan versus execution. There's a gap between the two of them, and this is the challenge that all humans face as well. Our plan versus the execution is oftentimes off. And what we consider as acceptable when we verify our execution changes oftentimes from when we started out. Right? Because maybe we are tired in our execution loops. So it's all kind of related, the way the space is going, and the fact that it is related tells us how close this is coming to human, to paralleling how humans work. Right? It's fascinating. Yeah. So 5 core problems. All of these are engineering problems. A lot of work also going on in each of them. We talked about many of them in brief. What else do we have here? Okay, so we talked about, of course, about how Claude code is built, and what are the different things inside that harness. We talked about an agentic pattern, the agent loop, right? And that's a very powerful loop. By default, there are lots of different agent patterns. You guys can look it up. But this is amongst the most effective ones that we ourselves, so we do a lot of AI consultancy, build for a lot of clients. And when we build agentic systems for them, this was amongst the most reliable that we could find to execute. Okay, so I would highly recommend, but you can read other agentic patterns as well. There are different ways to kind of build that ecosystem, right? Now, so we talked about agents, multi-agent systems, all the harness and all of that, right? Now, in the context of obviously 2 different agentic systems that are probably doing very well in the world today. Let's now step back to the aim of this video, which is your specific use case. Should you build an agentic workflow? How do I decide what needs to be done? Right? I'm going to draw a distinction here between agents. So forget about multi-agent workflows at all, right? So we'll just talk about single agent workflow, right? Agents versus workflows. Okay, and the two are different. Okay, there is a case for and a dominant case where most people should not build agents. Okay, I'm going to repeat myself, right? Majority of people for their use cases should not be building agents or agentic, any kind of agentic systems. You should be building something called as a workflow. Okay. Why is this, right? And what's the difference between the two of them? In case of a workflow, you have structured steps to decide what should be done first, what should be done next, what should be done third, etc., etc. So the flow of how it has to be executed is human determined, right? Human determined is how the flow is, because you have the domain knowledge to tell that, boss, do this first, do that next, do that next. Right? So let's take the classic example of doing construction. You will say, if you've done enough buildings and you have the domain expertise, you will say, before you buy the cement, please first look at other aspects. Don't go and buy the cement first. Right? So that is the kind of, that's a very rudimentary example, but hopefully it makes sense that obviously in construction, certain things had to be done before others. So there is a specific workflow. Now, construction is a very extreme use case, right? But any other digital, virtual, software-based use case that you can think of, if you know the workflow, Whether you're working, let's say you're a doctor and you want to, and you're working for doctors and you want to do some automation for them. Let's say diagnosis automation. You're evaluating if you have to build an agentic workflow. I should not be using the word agentic workflow. Agentic pipeline versus workflow. Workflow is something completely different, right? I think that's my bad. The two are completely different, right? If you know the steps, and a doctor would diagnose by looking at, first they would look at this, then they would look at that, then they would look at that, X, Y, Z. They'd look at scans, they'd look at your reports, they'd do a physical clinical examination, right? And in the clinical examination, if they find something else separate, or if the patient is complaining about something else, from there on, it would lead them to say, okay, do this additional test. So you oftentimes would have a mind map or a flow on how things have to be executed, right? I'm not an expert in the medical domain. I'm not a doctor. So I'm generalizing, of course. But in whatever field that you're in, if you find that there's a structured set of steps that you can impart onto the pipeline, that's the best decision that you can take, rather than giving the agent complete autonomy on choosing what it needs to do, right? Of course, within each of these steps, you can give it autonomy to say, okay, do this step first, right? Go and like search, let's say, medical records first. And for that specific step, give it freedom to do what it wants to do. So within that specific step, it can choose, okay, what kind of, do I need to use a MCP server? Do I need to use some internal tools? It can have autonomy within the step. But the workflow as such, if you have the domain expertise, that's the best thing that you can do, right? The more determinism that you can add to this pipeline, and it will make sense why I'm saying this in just a bit, right? The more determinism that you can add to the workflow, to convert it to a workflow, the better your consistency of execution is going to be like. So consistency is I think very, very critical here. So all your problems around hallucination, how your plan could hallucinate, your execution could drift from that, all of that becomes far better, right? We talked about some of these problems, your hallucinations, your drift between plan and execution, all this becomes far better as you move to a workflow. And also there's something very, very interesting which I will talk about in subsequent slides, okay? On this workflow versus agents, right? So workflows where there's a structured steps, human determined. Agent is where you tell the LLM, diagnose this patient, here is everything you have access to, figure it out. So it will then automatically decide how I should plan, what I should do, what should be my step sizing, what I should execute in each step, how I should delegate. It will do everything, and it will loop until it gets a satisfactory result, right? So there's a lot of dynamism to this workflow. This of course, I'm not workflow, but this agentic setup, right? The agentic setup will basically have the LLM deciding what action to take, how many times to take, right? Based on the output. It's complete autonomous decision making, but you give it autonomy. It can go into some very weird parallel loops of execution, right? So which means you need to have those guardrails. The verifier should be very, very powerful and important to keep it relevant, right? Your context also, the way it is engineered for some of those longer running sessions is also very, very critical. So there's a lot of stuff around that, in fact, which is very, very important, right? They can be powerful, right? Because they can execute things which are not determined by you. But for a vast majority of use cases, workflow is what I would recommend, right? So if you're at a point where you're determining should I go for workflow or agent, hopefully this entire session has given you insight on how complicated it is to build a successful agentic workflow. And by the way, not workflow, agentic pipeline. And by the way, getting this agentic pipeline into production is another challenge, because you need to look at observability and how you are going to iterate on that specific pipeline, because you're not just observing input and output, you're going to observing what tool calls, what order of those tool calls, what's the size of the planning, everything, right? You're going to look at every single aspect and optimize. Do you have the team size, the bandwidth, the budget, all of that to do all those exercises, right? More often than not, the answer to that is no. Therefore, it's going to be workflow for a vast majority of us. Okay. Forget even multi-agent systems, right? Workflow. Now, the other bit that I said most of you should choose workflow is because of the cost. Okay. Cost and time. This is something that I think we could get from a lot of these coding agents, right? I think there's a funny quote somewhere. I forget the exact quote, but it was something along the lines of, we are building agents to spend more money, essentially. Okay. just because we can, right? And there's a lot of talk that's going on about the AI bubble and how these companies are paying each other, and and that is justifying some of the cloud costs, etc., etc. So it feels a little bit circular and forced, right? But if you look at it purely from a cost perspective, as of today, which is I'm kind of recording this in August 2026. So things could change. You could get smaller, more efficient models, right? All of that is the direction that people are moving in. But as of today, a single agent, which is where you would, or even you could extend this to a workflow-based system as well, would cost about, say, $9. I think this comes from one of the surveys of Anthropic itself. Okay, I'll verify this again. Okay, I'll verify this again. My team put together this specific slide, and a full harness. It was, I think, one of their YouTube lectures that they mentioned something like this. Anthropic, right? And they mentioned the cost per task on their side for the full harness is roughly around $200, right? Which basically means two things. One is, obviously, workflows and agents are far more cost effective because they're going to be using fewer tokens, and they're not suited for everybody, having this kind of full harness, multi-agent setups, things like that going on. Even from a time perspective, if you obviously imagine you're having a multi-agent system and they're interacting with each other and all of that is going on, there's going to be a far higher execution time, right? So they found that several of these systems took 6 hours execution time. I again have to check the exact task that they were trying to do, right? It's there in some Anthropic article, if I'm not mistaken. But you can look at the cost differential between the two of them, right? And the second bit that this interestingly brings out to us is that today, when we are looking at paying a subscription of Claude Core or Codex or any of these guys, right, the cost of the model on a monthly cost per token, which is there, we are paying something like, say, $100, $200 for an entire month with a pretty generous, reasonable number of tokens and execution limit, right? For a single task that they were mentioning, which probably took 6 hours, this is the kind of cost that they are paying at their end. Which means that for our execution, they are bearing a huge amount of cost for our execution. So all these companies today are probably making loss, tremendous amounts of loss, because the compute is just that expensive, right? Which could be another argument for the AI bubble, but that's a separate discussion, right? But when you're looking at it from your business perspective, you need to keep in mind that if you're going with higher complexity, there comes a higher cost, and that higher cost is not a 2x, 3x cost, it can be a 20x cost in terms of pricing, right? And time, right? Time is also just as important, right? Okay, so that's the agentic system. So hopefully by the end of this session, I have almost dissuaded you to looking at agentic systems because of the complexity that comes with them, and go for more structured workflows. That should always be your version 1. If you think you cannot build a structured workflow, you don't have the domain expertise, you cannot do it, right? Or it is just not possible for the problem that you're working on, then there's a genuine use case for an agentic system. Right? So coding is an agentic system because there's so much dynamism. Your code base could be very different from my code base, and what I ask you to execute could be very different from what somebody else asked to execute, right? So the genuine use case is a coding agent, right? But for your specific use case, if I'm doing like an SEO based optimization, is a coding agent really required? I mean, does it have to be an agent? Can't it just be a specific workflow, a pipeline, in terms of cost, in terms of time? It's fun. It's fancy to show to your marketing guys and to your investors, okay, that I'm going to use a multi-agent workflow and we are the first agentic company and this and that. It's fancy, but you have to know the reality behind it from an engineering perspective. Okay, that's very, very critical. Okay, so again, the final piece that I would leave you with is, should you build an agentic system? Depends on do you have very, very complex multiple steps, and it probably cannot be solved with a single LLM call or a fixed workflow, right? A single call can't do a great job, nor can a fixed workflow do a great job. Oftentimes the path is unknown. Then agentic systems have a genuine use case. Okay. The next bit is, it's a little bit controversial, but you need to have a use case for why agentic systems would be better, right? And obviously the use case is, I'm assuming it's going to be more accurate. Why am I doing all this, like, giving it autonomy, let it decide what it wants to do? Is because I can't figure it out on its own, or what I can figure out is not accurate enough. So maybe it has some foundational intelligence which is far better than what I do by myself. In iterations, maybe we might work better together, but you prefer accuracy. And overspeed is a very specific thing that I've written here because they can be pretty time consuming, right? A single pass approach, a single call or a fixed workflow it has more determinism to it. You'll have a limited number of loops, right? You can still structure in loops for verifier and you can do those things, but it'll still be a workflow. Right? If you structure it that way, it's going to be less expensive, and you have to decide where you stand on the accuracy line for this. Is that good enough for you or not? Or maybe there are pieces that you have not yet figured out, right? You could go back and forth also sometimes. If it's easy enough for you, you could build an agentic system, get learnings from the agentic system, look for repeatability patterns, and then translate that back to a workflow, right? And then the final part is the cost justification, right? Obviously, I did mention a slide from Anthropic about the cost differential for a specific task that they were talking about, right? But you have to not just view it in the context of that task alone. You have to also view it in the context of the task that you are trying to automate. You're obviously trying to automate something, right? What is the cost today of you doing that specific task from a business perspective, right? Or even a personal perspective? What is the cost of that in terms of money, in terms of time? If somebody is doing a really manual review that's going to take 1 month long and you're anyway going to pay them, I don't know, say $1,000 for the month, right? You can then come and see, okay, if you got to take a call, right? If I'm going to spend $2,000 on this, but get that done in say 3 days, or I'm going to spend 10x the amount, $10,000 on this, but I get it done in 1 day. What is that worth to me at a business level? And that's how you have to justify it, right? You have to figure out if it makes sense for you. Okay, if that saving of 29 days is going to allow you to get those folks, or maybe you'd say, I'm going to do it in 2 days plus some manual verification, which is going to bring the overall thing to 1 week versus 1 month, and therefore I'm doing it in 25% of the time. So the remaining amount of time I'm going to be able to take on, that same person is going to be able to take on more work. So therefore we get in more clients, more business, whatever way it is, right? If it makes sense you have to figure out, does it make sense in the larger picture, right? So these are the use cases I would say you can think about. If any of these fit your equation, you can then look at agentic systems. But I must warn you that agentic systems, they are hot, but they are complex, right? And you will be iterating. You might get your first version 1 out really fast, but if you need to build a longer, larger ecosystem and pipeline, if that's one of your core products, and you have to iterate on that time and again, that iteration can be very painful and long because there are so many aspects that you have to iterate on. Of course, if you have the budget, the funds, if all of that is in the picture and you have a sign off from folks up above that they're okay with all of that, then sure, you have the money to exploratory money, you can go ahead with it, right? So this is agentic systems, and I'm hoping that we have basically come to the end of the session. Yeah, that's pretty much it. So we've come to the end of the session. So I'm hoping you have gotten an idea about how each of the jargons which are thrown around in this ecosystem, how they have come into picture, why they have come into picture, right? What is the complexity that exists with this space? It's very exciting. There's a lot of potential on what it can do for us. And I hope all of you make maximum use of it. Each of the terms that were discussed about can be dug in, like you can dig deep into that in far more depth. Every single term that we talked about, there's a lot of stuff on that. As you get to building things, which is my largest recommendation to everybody, build stuff, then you will be able to break this down very well, right? Because we build things for our clients in our AI consultancy, we have a lot of understanding on the practical aspects of these agentic systems. Similarly, you should build your own personal projects and get to doing things rather than just passively listening or watching or reading. Yeah. With that, I'm done with this video. I'll see you on the next one, guys. Hopefully you had it's a pretty long hour and a half, but I'm hoping that you enjoyed this session. Until next time, bye-bye.